Alright, here is the triangle mid-segment theorem video. Let's look at this first box. A mid-segment of a triangle is segment connecting the midpoints of two sides of a triangle. Example, DE would be the mid-segment of this triangle. So the midpoints here, D and E, those are going to be midpoints. And you can see, if you look at BC, you have your double dash here and double dash here, and they're trying to tell you that this side is cut in half into two equal parts. And a segment AB here has also got this dashes here showing you that this is the midpoint that cuts this into two equal parts. It is not showing you that side AB is congruent to side BC. They are showing you that these two halves are equal, and on this side, these two halves are equal. So let's look at what math is in this theorem. So if a segment joins the midpoint of two sides of a triangle, that is DE up here, then the segment is parallel to that third side. Okay? So let's look at our picture up here. I'm going to put in a symbol here that shows you these two pieces are the parallel sides. So DE, segment DE, is parallel to side AC. It's going to be parallel to the side that did not get the two midpoints in it. And DE is going to be half the size of AC. So, looking at this diagram up here, DE is parallel to AC. That's what this one's showing. That's the symbol for parallel. And DE is half of AC. So basically what we're going to do mathematically is say, we're just going to take the DE on this picture, which is the mid segment. We're always just going to multiply it by 2. That's what this little equation is showing. So we're always just going to multiply whatever this mid segment is by 2 when we're doing the math part of this. Alright, so let's zoom in here. Alright, so identify pairs of parallel segments. So I'll just give you one of these and move on. So let's look at WX. I'm just picking one of these. Let's look at segment WX. It is parallel to the side it doesn't touch. So it touches this side. It touches this side, so it's parallel to RS. It's parallel to the side it doesn't touch. Okay, and we could say XY, I guess I'll do one more, is parallel to QS. Parallel to the side it doesn't touch. Alright, so LM and N are midpoints. Okay, so we got cut, this side's cut in half, this side's cut in half, and this side. PQR is the big one. PR is 46. That means I'll have two 23s. Because all I did was cut it in half. Because I know that this is a midpoint, so I just did 46 divided by 2. PQ is 40. This is a midpoint, so this has to be 20. And LN, LN, I'm going to use a different color because LN is one of the sides of this inside triangle. Find each measure. Okay, so I know this guy right here, mathematically, and this thing right here, that 17 has to be half the size of this. So in all reality, look at this. See this blue line here? This is going to be the same length as that part. So I can do this much. I say this is 17, and now I know this piece is 17. Okay, now look at this part. See this 20 here? This is what you can do. With that 20, if I drag it through and keep it parallel, that piece right there, M to N, has to be 20. And I'm also going to do that with the 23. So here is the 23. Put it through there, keep it parallel, bam, there's my parallel line. That piece is 23. And that's how you can find the links to these things. All right, LM. I have everything labeled. L to M is 23. MN, wherever MN is 20. Q to R would be 17 plus 17. And M to R would just be half of that. So hopefully we get to do that again. I'll get to show you that math again. All right. So we got all these midpoints here. F to G is 9. So right away I know this much. So if this is 9, the piece that's parallel to that has also got to be 9. And H is a midpoint, so this piece has got to be 9. Okay? All right, so let's pick a different color. G to H is 7. That means the line parallel to that is equal to that. That would be FE. And F is a midpoint, so that means CF is also 7. CD is 24. That's an outside piece, but I know G is the midpoint, so that has to be 12 and 12. And the line parallel to that, the mid-segment parallel to that, is equal, so that's 12. So there's every little piece right there. So you can find CE, DE, FH, but the perimeter of CDE is that huge, or not huge, I guess, but the bigger triangle. So you would say this piece is 24, this piece is 18, and this piece is 14. To get the perimeter, you just add up all the sides. So you would say 14 plus 18 plus 24, and you'd get the perimeter of the big one. All right, so here is our first algebra problem with the midsegment and its side it's parallel to. Remember, let's go back up to here. We said that we're always just going to find the midsegment one, the one that's in the middle, and times it by 2. So, and then make them equal. So here is your midsegment. So I'm going to show you my math that I already did, where I multiplied that 7x by 2. So there's me multiplying my 7x by 2. Now I just go ahead and do that, do the math, and then we just get 6. Okay, on another one, this says find DE. So everybody that's watching this should know what to do. We solve for x and then plug x in to find the numerical length of DE. So here's my 4x plus 1. That is my midsegment, and that is the one I'm going to double. Okay? So there's me doubling it, making them equal. If I'm going too fast, just pause it. Or you can rewind it as well. There's me getting 9. And then here's me plugging 9 into here. So notice when I plug 9 in, I plug 9 into 4x plus 1. You only double it for the algebra part. Okay, so that's, you don't double it when you're plugging in and finding the length. So that's 9 times 4 plus 1. That's where I got 37 as my final answer. All right, looking at number 9. All kinds of stuff going on. But you got to find the perimeter of the JKL triangle, and that is the big one. Okay? So let me go ahead and see what I can find here. I do know this piece is parallel to this piece, and I know that has got to be 49. And that this is a midsegment, that's doubled. All right. So then I can do that with this side, 42. It's parallel to this little piece and equal to it. So that's 42. And that's a M is a midpoint, so that's 42 as well. So now I'm going to do my algebra parts to find KL. So I need X. KL is represented by 13x minus 10. So once I find X, I can throw it right here and say 13 times it minus 10, and I'll find the length of this big one. So here's the mid-segment that's parallel to it. Mathematically, we just double this one, 6x minus 1, and we're going to multiply it by 2. There's me putting a 2 in front of it and doubling it. And making it equal to 13x minus 10. Do some math, I get x equals 8. Okay, so then I'm going to go to KL. I'm going to throw that 8 in there. 13 times 8 minus 10 to get 94. And don't forget to find the perimeter of the big one. So I got that 42 plus 42 is 84. That's where the 84 came from. 49 plus 49 is the 98. And then I get the 94 from my KL, add it all together, and get 276 for the perimeter of the big one. JKL is the big triangle. All right, moving on to the next page. So when we see angles like this, once we know these are parallel, we can start thinking of parallel lines and that transversal, like crossing the river on that bridge. So here's what you got to see. Right here would be your easiest one to see. These two right here add up to 180. All right. Okay. Also, these two, you have to see same side interior angles. Those add up to 180. So angle 1 will be 53 because they add up to 180. Whoops. You need to see that these two are also same side interior angles. So that angle 5 is 121. 121 plus 59 is 180. If it isn't, we'll just correct my math real quick. I'm going fast. So this is 121 plus something adds up to 180. 59. Okay. So I need 2. So angle 2 would be, what we got? 53. 53, I guess. Yes, 53. And then how can I finish this off with angle 3? All you got to remember is this. You got to catch this triangle in here. That adds up to 180. That's how you're going to get angle 3. So you'll take your angle 2, your angle 4, subtract it from 180, and you'll have angle 3. Okay, one more time. So let's see. Angle 118 and 5 are same side interior angles. They add up to 180. So angle 5 is 62. And no, it does. You do not have to start in numeric order. You do not have to start at angle 1. 118 plus angle 1 add up to 180. So that's also 62. Okay, so if I have 62 for this angle 1, how am I going to get to 2, 3, and 4? Well, now we're going to use the triangle to get to 2, 3, and 4. So I'm going to take 180 and that blue triangle, subtract that 95 and subtract that 62. And this angle right here is 23. That's how I got that. And I just put it in my calculator just now. Then I'm going to do a half circle here. 23 minus 180 minus 23. I'm going to get 157. So this angle 3 is 157, and these two right here are same side interior angles and add up to 180. They're not equal, almost at equal. So that's how I got that. All right. So these two right here are going to be corresponding. Same position on a different intersection, okay? We've seen this before. So if we have parallel lines, there's your bridge. Corresponding angles are equal. So you would make these equal and solve for x, and you're done. Okay, these are same side interior angles. These are not equal. They're next to each other. They add up to 180. So you'd say 5x plus 2 plus 11x minus 30 adds up to 180, and solve for x that way. And real quick before I finish this, I'll talk about perpendicular bisector or angle bisectors, okay? So if this is a perpendicular bisector on this triangle, it cuts everything into equal parts. This basically acts as a mirror. So everything on the right side is equal to everything on the left side. And that's true over here, but if it says perpendicular bisector, that's the difference here, is this right angle. That's what makes it a perpendicular bisector. If it's just an angle bisector, so I call this the top part and this is the bottom part, this is your angle bisector, so that means everything on the top is equal to its corresponding part on the bottom. So take a look at this. If this is my bisector, this piece right here corresponds to this piece over here. They are equal. That's your math. Set these equal to each other and find x. Okay, if this is your bisector here, whoa, that was bad. That means these two are equal. Find x, plug it in, and you can start finding angles. This is pretty easy stuff. Just think this is a mirror, and everything on this side is equal to everything on that side, corresponding parts.